This is our last topic in light, and it's polarization. Polarization is defined as the process by which light is confined to a single plane. What is difficult for us to understand is that we normally draw a photon as traveling like this in a particular plane. This one happens to be the plane of the board. However, it could be in the plane of the floor or various planes. So it could be vibrating up and down like this, but the photon could also be vibrating back and forth like this, or at some crazy angle like this. And so light coming from the sun or most light sources is unpolarized, meaning you don't know what plane it's normally traveling in, and you can't tell just by looking at it. The process of confining it to one plane is what's called polarization, and there's reasons we want to do that. So let me explain the methods of polarization, how we polarize things, and then as we go, we'll explain why. The first method of polarization is by filtering. And filtering is by using, well, let me draw some pictures and maybe this will help you understand. The example we're going to use is called the picket fence example. So if we had a picket fence and somebody was vibrating a rope, and the picket fence was vertical, as you can see in this particular first case, and somebody's vibrating the rope vertically, it would go right through. And it would go through the second fence. However, in the lower picture, and now we're taking a look at this lower picture here, it makes it through the first fence, or the first filter, if you will, but then because it's vibrating in a vertical fashion, by the time it gets to the second filter, which is in the horizontal fashion, it won't go through. So a polarizing filter is actually just a piece of glass. Now let me see if I can draw this here. Is a piece of glass that would have in it very fine lines that would allow the light to pass through in only one direction. And you could orient that in any particular direction that you wanted. That's a filter. And there's a reason we want some filters. By the way, if you took two filters and you put one horizontal, one vertical, as you see in this picture down below, it would actually cut out the light. Right? So we can actually filter out which plane we want. Now, there's a reason for that, and as we go on further, I'll explain. The second method of polarization is by reflection. All right? Now, let me show you an example of this. When light reflects off a surface, and let me see if I can expand this out to make you see this better. When light reflects off a surface, it goes in unpolarized. And so over to the left here, we have a signification of unpolarized light. But when it comes off a surface, like the surface of water, it is polarized horizontally. Well, my question is, what happened to the rest of the light? As you know, any time a wave, or a photon in this case, hits a boundary, which happens to be water in this case, some of the waves go through and some reflect. Well, it just so happens, we do know this, that the waves that go through are the ones that are traveling vertically. But the ones that are traveling horizontally are the ones that have a better chance of reflecting off. And so light reflected off a roadway, for instance, or reflected off water or reflected off glass is often horizontally polarized. Now, I wouldn't say 100% polarized, but maybe polarized 80 or 90%. Well, what great advantage does this have for us? Knowing this, if we build ourselves a filter, if you recall in this last discussion we had about filters, if we build ourselves a filter and put it in the vertical fashion, it would cut out that horizontal light. Horizontal light won't go through a vertical filter. So let me show you this picture because this would explain it. Here we have a barrel of water with some rocks in it. And there's water in the barrel with the rocks. And when you look at the sunlight reflecting off the water, in the left picture, you can't see the rocks. But in the right picture, because of the filter, you can. You see the light reflecting off that water is horizontally polarized. So should we use a vertical filter, it'll cut that light out. And now we actually get to see the rocks down below the water. Fishermen love this sort of thing. People who fish want to wear polarized glasses. It gives them a better view. Actually, people who drive want to use polarized glasses. And I would encourage you when you're looking for sunglasses to look for polarized glasses. Now, I know the first rule of looking for sunglasses is they have to make you look cool. And that's an important, very important rule. But the second rule ought to be they also ought to be polarized. And there's plenty out there that do both. What polarized sunglasses do for you is light reflected off roadways or cars in front of you is kind of glaring light and kind of like causes you to squint. If you wear polarized sunglasses, it literally cuts out that light. And you can notice the difference when you wear polarized glasses, and this picture actually shows you that. Right? The third method of polarization is by refraction, and this is a rare method. And it doesn't happen very often, and let me show it to you. If we take, for instance, a piece of crystal, and the type of crystal that I'm going to use here in this particular case is called ispar, or, or, or actually calcite. That's what this is. When we send unpolarized light through it here, it has the tendency to split it up at two different refractive angles. This is something we've never seen. It bends one of the waves, the horizontal wave, at one angle and the vertical wave at the different angle. Why does it do this? We're not quite sure. But because it does it, it splits up the light. And it actually gives you a double image coming out the other end. Using a polarized filter, we can actually cut that out. And if you're in class, I actually will show you some of this material. Now, who would use this concept is guys who make glass. And I'm not so sure you can see this picture very well. But guys who make glass like windshields will use polarized glasses to look for imperfections in the windshields. They can see imperfections in the windshield by how the light refracts through it. And so the refraction of light is one method of polarization. And so polarization is kind of an interesting topic. And if you get a chance to wear polarized glasses, you'll know the difference. And in class, we do many demonstrations with this, but I thought you might find that interesting. This ends our series of lectures on light, and our next series of lectures will begin electricity.